Python tutorial for beginners. Full course in one lesson. Let's start. Downloading Python. Installing Python is a simple matter, regardless of which platform you're using. The first step is to obtain a recent distribution for your machine. The most recent one can always be found at www.python.org. I'll download Python for Windows. Installing Python. Python can be installed in most versions of Windows by using the Python installer program. Just download it, execute it, and follow the installer's prompts. You may need to be logged in as administrator to run the install. If you're on a network and don't have the administrator password, ask your system administrator to do the installation for you. The basic interactive mode and Hello World. The basic interactive mode is a rather primitive environment. Starting a basic session on Windows for version 3.7 of Python, you navigate to the Python command line entry on the Python 3.7 submenu of the Programs folder on the Start menu, and click it. Alternatively, you can directly find the python.txt executable and double-click it. Type print, Hello World, and press Enter. In this way you wrote your first program. Hello World has been displayed. Using the interactive prompt to explore Python. Whether you're in idle or at a standard interactive prompt, there are a couple of handy tools to help you explore Python. The first is the help function, which has two modes. Entering a type or variable name as a parameter for help gives you an immediate display of that type's documentation. Idle. You have two built-in options for obtaining interactive access to the Python interpreter, the original basic, command line, mode and idle. Idle is available on many platforms, including Windows, Mac, and Linux, but it may not be available on others. You may need to do more work and install additional software packages to get idle. To start idle, click Start menu, type Python and then click Idle Python 3.7. Idle is the built-in development environment for Python. Idle combines an interactive interpreter with code editing and debugging tools. It provides automatic indentation and colors your code as you type it in, based on Python syntax types. You can also use the help function here. Comments and built-in data types. For the most part, anything following a hash symbol in a Python file is a comment and is disregarded by the language. The obvious exception is a hash in a string. Python, like most other programming languages, indicates strings through the use of double quotes. This line leaves the string hello, world. Use the print function to display the data. Python's 4 number types are integers, floats, complex numbers, and booleans. X starts out referring to the string object, hello world, and then refers to the integer object, 8. A new assignment overrides any previous assignments. The del statement deletes the variable. Trying to print the variable's contents after deleting it gives an error the same as if the variable had never been created in the first place. You can manipulate numbers using the arithmetic operators, plus, addition, subtraction, multiplication, division, exponentiation, and percent, modulus. Division of integers with // results in truncation. This examples use complex numbers. Built-in functions are always available. Round is called with a float as its input argument. The last examples use booleans. Strings. Strings can be delimited by single, double, triple single, or triple double quotations and can contain tab, \t, and new line, \n, characters. The print function outputs strings. The simplest, and probably most common, way of combining Python strings is to use the string concatenation operator, plus. For the purposes of extracting characters and substrings, strings can be considered sequences of characters, which means you can use index or slice notation. You can include any ASCII character in a string by using an octal, base 8, or hexadecimal, base 16, escape sequence corresponding to that character. An octal escape sequence is a / followed by 3 digits defining an octal number. The ASCII character corresponding to this octal number is substituted for the octal escape sequence. Sequences of characters that start with a / and that are used to represent other characters are called escape sequences. Escape sequences are generally used to represent special characters, that is, characters, such as tab and new line, that don't have a standard one-character printable representation. Most string methods are attached to the string object they operate on by a dot, as in x.join. Join method takes a list of strings and puts them together to form a single string with the original string between each element. By changing the string used to join, you can put anything you want between the joined strings. Split method splits on any whitespace, not just a single space character, but you can also tell it to split on a particular sequence by passing it an optional argument. You can specify how many splits split should perform when it's generating its result, via an optional second argument. If you specify n splits, then split will go along the input string until it has performed n splits, generating a list with n plus 1 substrings as elements, or until it runs out of string. See how you can replace all white characters with -- using the join and split methods. You can use the functions int and float to convert strings into integer or floating point numbers, respectively. You may pass int an optional second argument, specifying the numeric base to use when interpreting the input string. If they're passed a string that can't be interpreted as a number of the given type, they will raise a value error exception. strip method returns a new string that's the same as the original string, except that any whitespace at the beginning or end of the string has been removed. Else strip and rstrip work similarly, except that they remove whitespace only at the left or right end of the original string. But you can change which characters strip, rstrip, and elstrip remove by passing a string containing the characters to be removed as an extra parameter. Note that strip removes any and all of the characters in the extra parameter string, no matter in which order they occur. Find takes one required argument, the substring being searched for. Find returns the position of the first character of the first instance of substring in the string object, or -1 if substring doesn't occur in the string. Find can also take one or two additional, optional arguments. The first of these, if present, is an integer start. It causes find to ignore all characters before position start in string when searching for substring. The second optional argument, if present, is an integer end. It causes find to ignore characters at or after position end in string. Our find is almost the same as find, except that it starts its search at the end of string and so returns the position of the first character of the last occurrence of substring in string. You can use two other string methods to search strings, starts with and ends with. These methods return a true or false result depending on whether the string they're used on starts or ends with one of the strings given as parameters. Both starts with and ends with can look for more than one string at a time. Count method counts how many times a substring can be found in another string. You can use the replace method to replace occurrences of substring, its first argument, in the string with new string, its second argument. The functions string.maketrans and string.translate may be used together to translate characters in strings into different characters. Lower converts all alphabetic characters in a string to lowercase, and upper does the opposite. Title capitalizes all words in a string. Swapcase converts lowercase characters to uppercase and uppercase to lowercase in the same string. You can use split to turn your string into a list of characters, but list function is easier to use. Removes everything after 22 char. To turn the list back into a string, use double quotation marks, dot and join. String objects also have several useful methods to report qualities of the string, whether it consists of digits or alphabetic characters. You can format strings in Python 3 using format method. The format method combines a format string containing replacement fields marked with curly brackets with replacement values taken from the parameters given to the format command. This example has three replacement fields, 0, 1, and 2, which are in turn filled by the first, second, and third parameters. No matter where in the format string we place 0, it will always be replaced by the first parameter, and so on. The format method also recognizes named parameters and replacement fields. Format specifiers let you specify the result of the formatting with even more power and control than the formatting sequences. The format specifier lets you control the fill character, alignment, sign, width, precision, and type of the data when it's substituted for the replacement field. You can format strings with the string modulus, % operator. This style of formatting shouldn't be used in new code, because it's slated to be deprecated and then removed from the language in the future. Formatted string literals are prefixed with F and are similar to the format strings accepted by str.format. They contain replacement fields surrounded by curly braces. The replacement fields are expressions, which are evaluated at runtime, and then formatted using the format protocol. Lists. A list in Python is much the same thing as an array in Java or C or any other language. It's an ordered collection of objects. You create a listed by enclosing a comma-separated list of elements in square brackets. Python lists can contain different types of elements. A list element can be any Python object. First element is a string, second is a number, third is another list. Len function returns the number of elements in a list. Python starts counting lists from 0, asking for element 0 returns the first element of the list, asking for element 1 returns the second element, and so forth. If indices are negative numbers, they indicate positions counting from the end of the list, with -1 being the last position in the list, -2 being the second to last position, and so forth. You can cut a fragment of the list by entering 2 indexes. Python can extract or assign to an entire sublist at once, an operation known as slicing. Instead of entering list index, to extract the item just after index, enter list index 1 : index 2, to extract all items including index 1 and up to, but not including, index 2 into a new list. When slicing a list, it's also possible to leave out index 1 or index 2. Leaving out index 1 means go from the beginning of the list, and leaving out index 2 means go to the end of the list. You can use list index notation to modify a list as well as to extract an element from it. You can use slice assignment to do a number of different things. For example, appends list to end of list. Appends list to front of list. You can use append method do appending a single element to a list. One problem can occur if you try to append one list to another. The list gets appended as a single element of the main list. The extend method is like the append method, except that it allows you to add one list to another. There is also a special insert method to insert new list elements between 2 existing elements or at the front of the list. Insert is used as a method of lists and takes 2 additional arguments. The first is the index position in the list where the new element should be inserted, and the second is the new element itself. The del statement is the preferred method of deleting list items or slices. The remove method isn't the converse of insert. Whereas insert inserts an element at a specified location, remove looks for the first instance of a given value in a list and removes that value from the list. If remove can't find anything to remove, it raises an error. You can catch this error using the exception handling abilities of Python. The reverse method is a more specialized list modification method. It efficiently reverses a list in place. Lists can be sorted using the built-in Python sort method. Sorting works with strings, too. The default key method used by sort requires that all items in the list be of comparable types. That means that using the sort method on a list containing both numbers and strings will raise an exception. Python also has the built-in function sorted, which returns a sorted list from any iterable. Sorted uses the same key and reverse parameters as the sort method. It's easy to test if a value is in a list using the in operator, which returns a Boolean value. You can also use the converse, the not in operator. To create a list by concatenating 2 existing lists, use the plus operator. Use the multiplication operator to produce a list of a given size, which is initialized to a given value. You can use min and max to find the smallest and largest elements in a list. If you wish to find where in a list a value can be found, rather than wanting to know only if the value is in the list, use the index method. It searches through a list looking for a list element equivalent to a given value and returns the position of that list element. Sum method sums elements if they can be added together. Count also searches through a list, looking for a given value, but it returns the number of times that value is found in the list. Tuples. Tuples are data structures that are very similar to lists, but they can't be modified. They can only be created. Creating a tuple is similar to creating a list. Assign a sequence of values to a variable. A list is a sequence that is enclosed by square bracket, a tuple is a sequence that is enclosed by round bracket. After a tuple is created, using it is so much like using a list. The main difference between tuples and lists is that tuples are immutable. An attempt to modify a tuple results in a confusing error message, which is Python's way of saying it doesn't know how to set an item in a tuple. You can create tuples from existing ones by using the plus and multiplication operators. Del commands also work. One-element tuples need a comma. Including a comma indicates the parentheses denote a tuple. Python permits tuples to appear on the left-hand side of an assignment operator, in which case variables in the tuple receive the corresponding values from the tuple on the right-hand side of the assignment operator. Python recognizes tuples in an assignment context even without the enclosing parentheses. Python 3 has an extended unpacking feature, allowing an element marked with a multiplication to absorb any number elements not matching the other elements. Note that the start element receives all the surplus items as a list, and that if there are no surplus elements, it receives an empty list. Packing and unpacking can be performed using list delimiters as well. Tuples can be easily converted to lists with the list function, which takes any sequence as an argument and produces a new list with the same elements as the original sequence. Similarly, lists can be converted to tuples with the tuple function. Sets. A set in Python is an unordered collection of objects used in situations where membership and uniqueness in the set are main things you need to know about that object. You can create a set by using set on a sequence, like a list. When a sequence is made into a set, duplicates are removed. After creating a set using the set function, you can use add and remove to change the elements in the set. The in keyword is used to check for membership of an object in a set. You can also use pipe to get the union, or combination, of two sets, ampersand to get their intersection, and caret to find their symmetric difference, that is, elements that are in one set or the other but not both. You can use minus operator to get new set with elements in X but not in Y. Or with Y without the elements occurring in X. Because sets aren't immutable and hashable, they can't belong to other sets. To remedy that situation there is another set type, frozen set, which is just like a set but can't be changed after creation. Because frozen sets are immutable and hashable, they can be members of other sets. Dictionaries. A dictionary is a collection which is unordered, changeable and indexed. In Python, dictionaries are written with curly brackets, and they have keys and values. Keys must be of an immutable type. This includes numbers, strings, and tuples. Values can be any kind of object, including mutable types such as lists and dictionaries. A dictionary is a way of mapping from one set of arbitrary objects to an associated but equally arbitrary set of objects. Actual dictionaries, thesauri, or translation books are a good analogy in the real world. To see how natural this correspondence is, here is the start of an English to Polish number translator. Len returns the number of entries in a dictionary. You can obtain all the keys in the dictionary with the keys method. It's also possible to obtain all the values stored in a dictionary, using values. You can use the items method to return all keys and their associated values as a sequence of tuples. Attempting to access a key that isn't in a dictionary is an error in Python. To handle this, you can test the dictionary for the presence of a key with the in keyword, which returns true if a dictionary has a value stored under the given key and false otherwise. The del statement can be used to remove an entry, key, value pair, from a dictionary. You can use the get function. It returns the value associated with a key, if the dictionary contains that key, but returns its second argument if the dictionary doesn't contain the key. You can obtain a copy of a dictionary using the copy method. The update method updates a first dictionary with all the key/value pairs of a second dictionary. For keys that are common to both, the values from the second dictionary override those of the first. We want to know how many times each word occurs in the sentence. Dictionaries can be used to do this easily. In mathematical terms, a matrix is a two-dimensional grid of numbers. It's also common for such matrices to contain many zero elements. In order to conserve memory, it's common for such matrices to be stored in a form where only the non-zero elements are actually stored. Such representations are called sparse matrices. It's simple to implement sparse matrices using dictionaries with tuple indices. For example, the previous sparse matrix can be represented as follows. Now, you can access an individual matrix element at a given row and column number by the following bit of code. Control flow, while loop, for loop and if-elif-else statement. The while loop is executed as long as the condition, which here is x less than y, is true. This is the loop block. It's possible for it to contain break, which ends the loop, and continue statements, which abort the current iteration of the loop. The full while loop looks like this. While condition, body, else, postcode. Condition is an expression that evaluates to a true or false value. As long as it's true, the body will be executed repeatedly. If it evaluates to false, the while loop will execute the postcode section and then terminate. If the condition starts out by being false, the body won't be executed at all, just the postcode section. The body and postcode are each sequences of one or more Python statements that are separated by new lines and are at the same level of indentation. The Python interpreter uses this level to delimit them. No other delimiters, such as braces or brackets, are necessary. The most general form of the if-then-else construct in Python is if condition 1, body 1 elif condition 2, body 2. Elif condition n-1, body n-1, else, body n. It says, if condition 1 is true, execute body 1, otherwise, if condition 2 is true, execute body 2, otherwise, and so on, until it either finds a condition that evaluates to true or hits the else clause, in which case it executes body n. A for loop in Python is different from for loops in some other languages. In Python, a for loop iterates over the values returned by any iterable object, that is, any object that can yield a sequence of values. For example, a for loop can iterate over every element in a list, a tuple, or a string. But an iterable object can also be a special function called range or a special type of function called a generator. If you use range with two numeric arguments, the first argument is the starting number for the resulting sequence and the second number is the number the resulting sequence goes up to, but doesn't include. To count backward, or to count by any amount other than 1, you need to use the optional third argument to range, which gives a step value by which counting proceeds. The enumerate function returns tuples of index, item. You can access the item without the index. The index is also available. Sometimes it's useful to combine two or more iterables before looping over them. The zip function will take the corresponding elements from one or more iterables and combine them into tuples until it reaches the end of the shortest iterable. The pattern of using a for loop to iterate through a list, modify or select individual elements, and create a new list or dictionary is very common. This sort of situation is so common that Python has a special shortcut for such operations, called a comprehension. You can think of a list or dictionary comprehension as a one-line for loop that creates a new list or dictionary from another list. You can even use if statements to select items from the list. If we want to do something similar to the previous example but have the number be the key and the numbers triple be the value in a dictionary. Python uses the indentation of the statements to determine the delimitation of the different blocks, or bodies, of the control flow constructs. A block consists of one or more statements, which are usually separated by new lines. Multiple statements may be placed on the same line if they are separated by semicolons. Improperly indented code will result in an exception being raised. We indented a line that should not have been indented. The same message would occur if we didn't indent where necessary, that is, the first line after a compound statement clause. Let's fix the error. You can explicitly break up a line using the \. character. You can also implicitly break any statement between tokens when within a set of, or, delimiters, that is, when typing a set of values in a list, a tuple, or a dictionary, or a set of arguments in a function call, or any expression within a set of brackets. In Python 0 or empty values are false, and any other values are true. You can compare objects using normal operators, less than equals, greater than equals, and so forth. Equals is the equality test operator, and either exclamation mark or less than greater than may be used as the not equal to test. Expressions that return a Boolean value may be combined into more complex expressions using the and, or, and not operators. Python offers a nice shorthand for this particular type of compound statement. Functions. The basic syntax for a Python function definition is def name parameter 1, parameter 2, and subsequent parameters, body. As it does with control structures, Python uses indentation to delimit the body of the function definition. The following simple example puts the factorial function. The second line is an optional documentation string or docstring. You can obtain its value by printing fact.__doc__. The intention of docstrings is to describe the external behavior of a function and the parameters it takes, whereas comments should document internal information about how the code works. Let's execute the function. The return value isn't associated with a variable. The fact function's value is printed in the interpreter only. The return value is associated with the variable x. Most functions need parameters, and each language has its own specifications for how function parameters are defined. Python is flexible and provides 3 options for defining function parameters. Let's create a function counting the power of numbers. The simplest way to pass parameters to a function in Python is by position. When the function is called, the parameters used in the calling code are matched to the function's parameter variables based on their order. You can also pass arguments into a function using the name of the corresponding function parameter, rather than its position. Because the arguments to power in the final invocation of it are named, their order is irrelevant. You can pass first parameters to a function by position, and next pass arguments by parameter name. Inverse order will return an error. Function parameters can have default values, which you declare by assigning a default value in the first line of the function definition. Parameters with default values must be defined as the last parameters in the parameter list. The following function also computes a to the power of b. But if b isn't given in a call to the function, the default value of 2 is used. Python functions can also be defined to handle variable numbers of arguments. Prefixing the final parameter name of the function with * causes all excess non-keyword arguments in a call of a function, that is, those positional arguments not assigned to another parameter, to be collected together and assigned as a tuple to the given parameter. Here's a simple way to implement a function to find the minimum in a list of numbers. Now, test out the behavior of the function. Any variables in the parameter list of a function, and any variables created within a function by an assignment, are local to the function. You can explicitly make a variable global by declaring it so before the variable is used, using the global statement. Global variables can be accessed and changed by the function. They exist outside the function and can also be accessed and changed by other functions. You can use one function inside an execution to another function. You can define local functions inside other functions. Lambda expressions are anonymous little functions that you can quickly define inline. Often, a small function needs to be passed to another function, like the key function used by a list sort method. In such cases, a large function is usually unnecessary, and it would be awkward to have to define the function in a separate place from where it's used. This defines lambda expressions as values of the dictionary. Note that lambda expressions don't have a return statement, because the value of the expression is automatically returned. Modules. Modules are used to organize larger Python projects. The Python standard library is split into modules to make it more manageable. You don't need to organize your own code into modules, but if you're writing any programs that are more than a few pages long, or any code that you want to reuse, you should probably do so. Module is a file containing code. A module defines a group of Python functions or other objects, and the name of the module is derived from the name of the file. Modules most often contain Python source code, but they can also be compiled C or C++ object files. Compiled modules and Python source modules are used the same way. Create first module. Create a text file called if-elif-else, and in that text file enter the Python code. Save this for now in the directory where your Python executable is. This code merely assigns pi a value and defines two functions. The pi filename suffix is strongly suggested for all Python code files. It identifies that file to the Python interpreter as consisting of Python source code. As with functions, you have the option of putting in a document string as the first line of your module. Save if-module.py module. Now, start up the Python and type pi or triangle_area, open round bracket, 3, 5 and close round bracket. Python doesn't have the constant pi or the function triangle_area built in. We've brought in the definitions for pi and triangle_area from the if-module.py file, using the import statement, which automatically adds on the pi suffix when it searches for the file defining the module named if-module. But the new definitions aren't directly accessible. We access pi and triangle_area by prepending them with the name of the module that contains them. The second form of import statement permits specific names from a module to be explicitly imported into the code. The circle_area function has not been imported, so it cannot be used without the module name. There's a general form of the from import statement. The asterisk stands for all the exported names in module name. This imports all public names from module name. You should take care when using this particular form of importing. If two modules both define a name, and you import both modules using this form of importing, you'll end up with a name clash, and the name from the second module will replace the name from the first. It also makes it more difficult for readers of your code to determine where names you're using originate. Exactly where Python looks for modules is defined in a variable called path, which you can access through a module called sys. In order to ensure that your programs can use modules you coded, you need to do one of the following. Place your modules into one of the directories that Python normally searches for modules. Place all the modules used by a Python program into the same directory as the program. Create a directory, or directories, that will hold your modules, and modify the sys.path variable so that it includes this new directory. The third option is the right choice for site-specific modules that will be used in more than one program at that site. The third option is the right choice for site-specific modules that will be used in more than one program at that site. To see this in action, let's assume we have a file called ortus.py, containing this code. As you can see, the names XX and AAA are imported, but the _YY remain hidden outside of ortus. Note that this behavior occurs only with from import asterisk. One thing that sometimes catches new Python programmers is the fact that you can override items in the built-in module. If, for example, you create a list in your program and put it in a variable called list, you can't subsequently use the built-in list function. The entry for your list is found first. There's no differentiation between names for functions and modules and other objects. The most recent occurrence of a binding for a given identifier is used. We can use two built-in functions, locals and globals. They return dictionaries containing the bindings in the local and global namespaces. You can use the del statement to remove these new bindings from the namespace. And last but not least, a curiosity, if you're using idle, you can graphically look at the search path and the modules on it using the Path Browser window, which you can start from File menu of the Python shell window. Programs. Any group of Python statements placed sequentially in a file can be used as a program, or script. But it's more standard and useful to introduce additional structure. In its most basic form, this is a simple matter of creating a controlling function in a file and calling that function. In this script, main is our controlling and only function. It's first defined, and then it's called. If you're using Windows, open Command Prompt. This opens in your home folder, and if necessary you can use the cd command to change to a subdirectory. Execute the script. The program displays the text. A simple mechanism is available for passing in command line arguments. You can see that the command line arguments have been stored in sys.targf as a list of strings. If we call this, we get the list of strings. Run the script several times for different arguments. You can redirect the input in or the output for a script using command line options. This script reads its standard input and writes to its standard output whatever it read, with all occurrences of its first argument replaced with its second argument. Let's see the file that will be read by our script. This script will place in second file.txt, a copy of first file.txt, with all occurrences of first replaced by second. The second file.txt file with the target content was created. Using the file system. Whenever Python is running, it has a concept of where in the directory structure it is at any moment. This is important because the program may ask for a list of files stored in the current directory. Use the os.getCould command to find out what Python's initial current working directory is. This command returns a list of all of the files or folders inside the current working directory. The constant os.curter returns whatever string your system happens to use as the same directory indicator. On both Unix and Windows, this is a single dot, but to keep your programs portable, you should always use os.curter instead of typing just the dot. The os.path.join function interprets its arguments as a series of directory names or file names, which are to be joined to form a single string understandable as a relative path by the underlying operating system. In a Windows system, that means path component names should be joined together with backslashes. If you need to get the path to the directory 2 levels up, use os.ster, open round bracket, quote, dot dot, quote, close round bracket. The os.path.split command returns a 2-element tuple splitting the base name of a path, the single file or directory name at the end of the path, from the rest of the path. The os.path.basename function returns only the base name of the path. The os.path.dirname function returns the path up to but not including the last name. To handle the dotted extension notation used by most file systems to indicate file type, the Macintosh is a notable exception. Python provides os.path.splitExt. os.path.expanduser expands username shortcuts and paths. os.path.expandvars does the same for environment variables. The most commonly used Python path information functions are os.path.exists, os.path.isFile, and os.path.tester, which all take a single path as an argument. os.path.exists returns true if its argument is a path corresponding to something that exists in the file system. os.path.isFile returns true if and only if the path it's given indicates a normal data file of some sort. Executables fall under this heading, and it returns false otherwise, including the possibility that the path argument doesn't indicate anything in the file system. os.path.ister returns true if and only if its path argument indicates a directory. It returns false otherwise. The os.name constant returns the name of the Python module imported to handle the operating system specific details. os.name returns NT if actual operating system is Windows. On a Mac running OS X and on Linux, Unix, the response is POSIX. You can use this to perform special operations, depending on the platform you're working on. Here are some examples of the use of os.path.exists. Here are some examples of the use of os.path.ister and os.path.isFile. The glob function from the glob module, named after an old Unix function that did pattern matching, expands Linux, Unix shell-style wildcard characters and character sequences in a path name, returning the files in the current working directory that match. A asterisk matches any sequence of characters. A question mark matches any single character. A character sequence, H, or 0 to 9, matches any single character in that sequence. To rename, move, a file or directory, use os.rename. Remove a data file with os.remove. To create a directory, use os.makedirs or os.dir. The difference between them is that os.dir doesn't create any necessary intermediate directories, but os.makedirs does. Folder new_dir undoubtedly exists. To remove a directory, use os.remdir. This removes only empty directories. Attempting to use it on a non-empty directory raises an exception. The copytree function of the shuttle module recursively makes copies of all the files in a directory and all of its subdirectories, preserving permission mode and stat, that is, access/modify times, information. It also has earnTree function, for removing a directory and all of its subdirectories. Many more functions can be found in the Python documentation. Reading and writing files. In Python, you open and read a file using the built-in open function and various built-in reading operations. Open doesn't read anything from the file, instead it returns an object called a file object that you can use to access the open file. A file object keeps track of a file and how much of the file has been read or written. All Python file I/O is done using file objects rather than file names. The first argument to the open function is a path name. The second argument of the open command is a string denoting how the file should be opened. R means open the file for reading, W means open the file for writing, any data already in the file will be erased, and A means open the file for appending, new data will be appended to the end of any data already in the file. The first call to readline returns the first line in the file object, the next call to readline would return the second line, and so on. You close file objects using the close method, after the file object is no longer needed. You can use open without the keyword with. If you want to read all the lines of a file in a list, you can also use readlines function. It's also possible to overflow memory with readlines if you have the misfortune to try to read a huge file. If you want to read the whole file, you should use whle or for loop. Let's open the file in the write mode. The converses of the readline and readlines methods are the write and writelines methods. Note that there is no writeline function. Write writes a single string, which can span multiple lines if new line characters are embedded within the string. If you open the file in a mode, you can add new lines to existing ones. Sometimes, you want to access the data in a file as a string of bytes, with no translation or text encoding. To do this, you need to open files in binary mode, which will return a bytes object, instead of a string when reading. To open the file in binary mode, use the binary argument with the mode open file, RB, or open file, WB. The path object, already discussed in this tutorial, allows you to read and write to a file without using the open and close methods. You can read and write binary files. You can use the built-in input method to prompt for and read an input string. Input writes its prompt to the standard output and reads from the standard input. Lower-level access to these and standard error can be had using the sys module, which has sys.stin, sys.stout, and sys.str attributes. These can be treated as specialized file objects. For sys.stin, you have readline, and readlines methods. For sys.stout and sys.str, you can use the standard print function as well as the write and writelines methods, which operate as they do for other file objects. Exceptions. Exceptions are raised by many of the Python built-in functions. Error-checking code built into Python detects that the second input line requests an element at a list index that doesn't exist and raises an index error exception. This exception propagates all the way back to the top level, the interactive Python interpreter, which handles it by printing out a message stating that the exception has occurred. The important thing about exceptions isn't that they cause a program to halt with an error message. By defining appropriate exception handlers, you can ensure that commonly encountered exceptional circumstances don't cause the program to fail. The basic Python syntax for exception catching and handling is as follows, using the try and except and sometimes the else keywords. In our case, we captured an exception, displayed a message and assigned 0 to variable a. The finally clause of a try statement is also optional and executes after the try, except, and else sections have executed. If an exception is raised in the try block and isn't handled by any of the except blocks, that exception is re-raised after the finally block executes. Because the finally block always executes, it gives you a chance to include code to clean up after any exception handling by closing files, resetting variables, and so on. You can easily define your own exception. These two lines creates a class that inherits everything from the base exception class. You can raise, catch, and handle it like any other exception. Exceptions may also be raised explicitly in your own code, through the use of the raise statement. A good example of exception handling in Python is the function that converts a text string into the number. If it is not possible to convert the text into a number, A Python returns the value error. You have to catch this exception and handle it. And then you can test the function. Classes. A class in Python is effectively a data type. You define a class with the class statement. The body can be just a single pass statement. This short example defines a class called myCircle and assigns to the radius field of the circle. You can initialize fields of an instance automatically by including an _init_initialization method in the class body. This function is run every time an instance of the class is created, with that new instance as its first argument. By convention, self is always the name of the first argument of _init_self is set to the newly created circle instance when _init_init_ is run. First we create a myCircle instance object and then we display its radius. Radius is an instance variable of myCircle instances. That is, each instance of the myCircle class has its own copy of radius, and the values stored in that copy may be different from the values stored in the radius variable in other instances. A method is a function associated with a particular class. In the example, we define two methods, special method _init__ and circle area method, which can be used to calculate and return the area for any myCircle instance. Method invocation syntax consists of an instance, followed by a period, followed by the method to be invoked on the instance. Methods may be invoked with arguments if the method definitions accept these arguments. Our definition does not accept any argument. This version of myCircle class adds an argument to the _init__ method, so that we can create circles of a given radius without needing to set the radius after a circle is created. Self.radius is the instance variable called radius. p_radius by itself is the local function variable. Using this definition of myCircle, we can create circles of any radius with one call on the circle class. This creates a myCircle of radius 10. A class variable is a variable associated with a class, not an instance of a class, and is accessed by all instances of the class. A class variable is created by an assignment in the class body, not in the _init__ function. In this example we will create a class variable called pi. We're accessing myCircle.py before any circle instances have been created. Obviously, myCircle.py exists independently of any specific instances of the myCircle class. You can try to change the value of the class variable in the instance, but as you can see from the result returned by the circle area method, the value of the class variable is not changed. The class named myCircle is represented internally by an abstract data structure, and that data structure is exactly what is obtained from the _class __ attribute of C, an instance of the myCircle class. This lets us obtain the value of circle.py from C without ever explicitly referring to the myCircle class name. You can invoke static methods even though no instance of that class has been created, although you can call them using a class instance. To create a static method, use the @static method decorator. All _circles, variable containing list of all circles that have been created. In this example, we will count the sum of all wheel radiuses. Let's see how the total underscore radius variable looks after creating several myClass instances. When you display the all underscore circles list, you will see 3 created instances. Class methods are similar to static methods in that they can be invoked before an object of the class has been instantiated or by using an instance of the class. But class methods are implicitly passed the class they belong to as their first parameter, so you can code them more simply. The class method decorator is used before the method def. The class parameter is traditionally mySir. You can use mySir instead of self.__class__. Inheritance in Python is easier and more flexible than inheritance in compiled languages such as Java and C++. To see how inheritance is used in Python, we start with the myShape class WTH2 variables, x and y. The first requirement for inheritance is defining the inheritance hierarchy, which you do by giving the classes inherited from, in parentheses, immediately after the name of the class being defined with the class keyword. In this code, my circle and my square both inherit from my shape. The second element is the necessity to explicitly call the __init___ method of inherited classes. You can use the super function to have Python figure out which inherited class to use. Let's create class instances. Inheritance allows an instance to inherit attributes of the class. Instance variables are associated with object instances, and only one instance variable of a given name exists for a given instance. The object BB in this example is an instance of class BB. BB inherits from AA, but BB doesn't inherit from some invisible instance of class AA. It inherits methods and class variables directly from AA. Because there is only one instance, BB, any reference to the instance variable x in a method invocation on BB must refer to bb.x. This is true regardless of which class defines the method being invoked on BB. As you can see, when they're invoked on BB, both set_AA and print_AA, defined in class AA, refer to the same variable referred to by set_BB and print_BB when they're invoked on BB. Any method or instance variable whose name begins with a double underscore but doesn't end with a double underscore is private, anything else isn't private. Variable __b is a private variable. Trying to access it directly raises an error. The print_b method isn't private, and because it's in the myClass class, It can access __b and print it. Python allows you as the programmer to access instance variables directly, without the extra machinery of getter and setter methods. But in some situations, using getter and setter methods can be handy. Suppose you want to calculate a value on the fly before you assign it to a variable. In Python, you can achieve this by using property. To create a property, you use the property decorator with a method having the property's name. Without a setter, such a property is read-only. To change the property, you need to add a setter. Notice that the name of the method remains the same, but the decorator changes to the property name, speed in this case, plus setter to indicate that a setter for the speed property is being defined. The 100 in speed _km is converted to miles before it's returned. The 200 is converted back to kilometers by the setter. Regular expressions. A regular expression, re, is a way of recognizing and often extracting data from certain patterns of text. A regular expression that recognizes a piece of text or a string is said to match that text or string. An re is defined by a string in which certain of the characters, the so-called metacharacters, can have a special meaning, which enables a single re to match many different specific strings. It's easier to understand this through example than through explanation. We saved the lyrics of Nothing Else Matters song to a file, and now we will try to find all the occurrences of the word nothing. The program starts by importing the Python regular expression module, called re. It then takes the text string nothing as a textual regular expression and compiles it into a compiled regular expression, using the re.compile function. This isn't strictly necessary, but compiled regular expressions can significantly increase a program's speed, so they're almost always used in programs that process large amounts of text. You can use the regular expression compiled to recognize other instances of the word nothing within another string. In other words, you can use it to determine whether another string contains nothing as a substring. This is accomplished by the search method, which returns none if the regular expression isn't found in the string argument. Python interprets none as false in a Boolean context. If the regular expression is found in the string, then Python returns a special object that you can use to determine various things about the match. In our case, we increase the value of the variable 0, which is the counter. This regular expression uses the vertical bar special character, pipe. A special character is a character in a regular expression that isn't interpreted as itself, it has some special meaning. Pipe means or, so the regular expression matches nothing or nothing. Another way of doing this match, in addition to using pipe, this regular expression uses the parentheses special characters to group things, which in this case means that the pipe only chooses between a small or capital N. The resulting regular expression matches either an N or an N, followed by othing. Another way of performing the match, the special characters open square bracket and close square bracket take a string of characters between them and match any single character in that string. There's a special shorthand to denote ranges of characters in open square bracket and close square bracket. Open square bracket, AZ, close square bracket will match a single character between A and Z. Open square bracket 09AZ close square bracket will match any digit or any uppercase character, and so forth. Sometimes you may want to include a real hyphen in the square brackets, in which case you should put it as the first character to avoid defining a range. Open square bracket -012 close square bracket will match a hyphen, or a 0 or a 1 or a 2, and nothing else. Assume that we wish to search some text for an occurrence of the string \the. Because we know that we have to represent a backslash as a double backslash, we might try. This will compile without complaining, but it's wrong. The problem is that backslash also means a single backslash in Python strings. Before re.compile is invoked, Python interprets the string we typed as meaning \10, which is what is passed to re.compile. In the context of regular expressions, \t means tab, so our compiled regular expression searches for a tab character followed by the two characters he. To fix this while using regular Python strings, we need 4 backslashes. Python interprets the first 2 backslashes as a special sequence representing a single backslash, and likewise for the second pair of backslashes, resulting in 2 actual backslashes in the Python string. That string is then passed into re.compile, which interprets the 2 actual backslashes as an re special sequence representing a single backslash. A raw string looks similar to a normal string, except that it has a leading R character immediately preceding the initial quotation mark of the string. As you can see, you can use raw strings with either the single or double quotation marks and with the regular or triple quoting convention. You can also use a leading R instead of R if you wish. No matter how you do it, raw string notation can be taken as an instruction to Python saying, don't process special sequences in this string. Raw strings aren't a different type of string. They're a different way of defining strings. It's easy to see what's happening by running a few examples. One of the most common uses of regular expressions is to perform simple pattern-based parsing on text. Suppose, for example, we have a list of pet owners and phone numbers in a text file. Each line of the file will look like this. With a surname, followed by a space, followed by a first name, followed by a comma and a space, followed by a pet, followed by colon and a space, followed by a phone number. But to make things complicated, the pet may or may not exist, and the phone number may or may not have an area code. We can use the square bracket special characters to define a pattern that defines only surname characters. The plus meta character repeats whatever comes before it 1 or more times as necessary to match the string being processed. Phone number, the special sequence, D matches any digit, and a hyphen outside of square brackets is a normal hyphen. That's colon and space, optional parenthesis, 2 digits, parenthesis and hyphen, followed by 3 digits, followed by a hyphen, followed by 3 digits, followed by a hyphen, followed by 3 digits. The problem is that, whereas this pattern will let us check to see if a line has the anticipated format, we can't extract any data yet. Notice that we have split up our regular expression pattern using the fact that Python will implicitly concatenate any set of strings separated by whitespace. As your pattern grows, this can be a great aid in keeping it maintainable and understandable. Fortunately, you can use regular expressions to extract data from patterns, as well as to check to see if the patterns exist. The first part of doing this is to group each subpattern corresponding to a piece of data you wish to extract using the round bracket special characters and then give each subpattern a unique name with the special sequence, question mark, p, open angle bracket, name and close angle bracket. We can find out whether a match succeeded by checking the value returned by search. If the value is none, the match failed, otherwise, the match succeeded, and we can extract information from the object returned by search. Now that we have named the elements of the pattern, we can extract them as matches are made, by using the group method. This is possible because when the search function returns a successful match, it doesn't just return a truth value, it returns a data structure that records what was matched. Because the animal is optional, we can't count on it having a value, even if the match as a whole is successful. If the match succeeds, but the match for the animal doesn't, then using group to access the data associated with the animal will return the value none. Part of the phone number is optional, but part isn't. If the match succeeds, the phone subpattern must have some associated text, so we don't have to worry about it having a value of none. In addition to extracting strings from text, you can use Python's regular expression module to find strings in text and substitute other strings in place of those that were found. You accomplish this using the regular substitution method sub. The sub method uses the invoking regular expression, regexp, in this case, to scan its second argument, text, in the example, and produces a new string by replacing all matching substrings with the value of the first argument, to be, in the example. Packages. When you understand modules, packages are easy, because a package is a directory containing code and possibly further subdirectories. A package contains a group of usually related code files, modules. The name of the package is derived from the name of the main package directory. Let's create a directory and file structure as in this picture. Files are marked with a dashed line. In each directory there is a __init__.py file. A Python requires that there is a __init__.py file for the directory to be considered a package. Our file __init__.py assigns the var variable a value of 1.01 and displays a message. The file __init__.py in cat1 directory displays a message. In file c1.py we have several variables. The __init__.py file in cat2 directory displays a message. In cc1 file we have several imports and one defined function called gg, which calls the hh function from another file. In the cc2 file we have a function hh. Files within a package don't automatically have access to objects defined in other files in the same package. As in outside modules, you must use import statements to explicitly access objects from other package files. You can add more dots to move up more levels in the package hierarchy, and you can add module names. We could also have written the imports of cc1.py as If all goes well, you should get another input prompt and no error messages. As well, the message "Welcome, this is your package" should be printed to the screen, by code in the your package, __init__.py file. The your package, __init__.py file assigns 1.01 to the variable var. Var is in the scope of the your package namespace, and after it's created, you can see it via our package, even from outside the your package, __init__.py file. Importing cat1 directory from our package will display two messages from two files __init__.py. After importing the C1 file you can use the X, Y, Z and W. Loading the top-level module of a package isn't enough to load all the submodules. This is in keeping with Python's philosophy that it shouldn't do things behind your back. Clarity is more important than conciseness. Importing cat2 directory will display three messages. When we import cc2, we can use the gg function. The gg function will start the hh function. Using Python libraries. In Python, what's considered the library consists of several different components. It contains built-in data types and constants that can be used without an import statement, like numbers and lists, as well as some built-in functions and exceptions. The largest part of the library is an extensive collection of modules. If you have Python, you also have libraries to manipulate diverse types of data and files, to interact with your operating system, to write servers and clients for many internet protocols, and to help develop and debug your code. Let's try a sample code from the Turtle module. In Python, thanks to the standard library, you can create window applications. Just use the tkinter module. These are just some examples, and all this is standard. Although Python's batteries included philosophy and well-stocked standard library mean that you can do a lot with Python out of the box, there will inevitably come a situation where you need some functionality that doesn't come with Python. Then you need to find the right module, and with the pip tool you can install it. To install the library, type pip in the command line, then install, and finally the library name. When the library is installed, you can upgrade it by adding a upgrade before its name. To uninstall the library, you have to use uninstall instead of install and confirm your choice by entering Y. Although Tuples packages get the job done, there's one catch: you have to find the correct package, which can be a chore. And after you've found a package, it would be nice to have a reasonably reliable source from where to download that package. To meet this need, there have been different Python package repositories over the years, and currently the official, but by no means the only, repository for Python code is the Python Package Index, or PyPy, also known as the Cheese Shop. You can access it from a link on the main page or directly at pippy.org. That's all for now. I hope you liked the course. Visit our channel, learn with video tutorials,